there. This is the beginning of the Trig track if you're taking this option for the Algebra 3 class. And we are going to start with some right triangle trig. And the beginning of right triangle trig is Pythagorean theorem. So this is 5.2, and it is Pythagorean theorem. I have to move something. There we go. So I know that you have seen Pythagorean theorem before. A squared plus b squared equals c squared, where c squared is the hypotenuse of a right triangle. So in that right triangle, I'd be all fancy and draw one for you, but it would just take too long and I'd probably find the wrong tool. Anyway, right triangle, that little, you know, upside down half a box indicates that this is a 90-degree angle, which means that this is a right triangle. Your hypotenuse is always directly across from that. It is the longest side in the triangle. These are just review items, things that I assume that you know. Also, know that all triangles have angles that add to equal 180 degrees, right? So if this one is 90, then these two have to also equal 90 together. But if we know two of the three, we can take 180 and subtract off the right angle, subtract off the other angle we might know, and that'll equal the missing one, right? So we're going to be doing a bunch of those things. I'm going to do one example with Pythagorean theorem, but then what we're going to get into are the trig ratios, all six of them, not just sine, cosine, and tangent, but also cosecant, secant, and cotangent. Okay, so let's see here. What do we want to say? You're going to use Pythagorean theorem, use to find a missing side in a right triangle. Okay, we're going to be using some non-right triangles here in 5.5, but you will either be using law of sines or law of cosines to do that. And those will be non-right triangles. So that's how you'll know not to use Pythagorean theorem. Okay, here's just a note on labeling a triangle. And I don't know if you already know this or not, so I'm going to throw it out here. So labeling. You're going to label your sides with lowercase letters. And your angles with capital letters. Always. Okay, so if we have a triangle, let's throw one in here. C is usually your right angle. Okay. And then maybe angle A is here and angle B is here. Okay, those would be your angles. And then note that your sides are always across from their corresponding angles. So side A is across from angle A, and side B is across from angle B. Side C, that's why angle C is always our right angle, is always your hypotenuse. Okay? So back when you learned Pythagorean theorem, you were told that A and B are interchangeable. Well, now you might be given specific pieces of information for A and B, and they are also going to represent specific sides of triangles in terms of opposite, adjacent, and hypotenuse, right? So we're going to want to watch out for those. Okay. Let's go to the next screen. So let's do an example here. Yeah, here's an example. If A equals 16 and C equals 34, find B. Okay, well, this is, and it says answer exactly. And we'll talk more about that when we solve the problem. So, formula, A squared plus B squared equals C squared. I've already done the math on another sheet of paper, so I know what these numbers should look like, but we're going to plug 16 in for A. So 16 squared plus B squared equals 34 in for C, so 34 squared. And then 16 squared is 256 plus B squared equals 1156. Okay, I want to get B by itself because that's the thing I don't know. So I'm going to go minus 256 minus 256. That's going to cancel. So B squared is going to be equal to 900. Remember that to get the answer to these, you're going to take the square root of B squared to get B, right? Because this will cancel this. And I'm going to take the square root in order to get my answer. Well, if this is not a perfect square, then make sure you reduce the radical. Do not put a decimal answer in. Into varsity if it says answer exactly. And this one does happen to come out to be a perfect square. The square root of 900 is 30. Okay, so this one would be B equals 30. But if instead, so here's what I mean by that. If we had B squared equal to 300 instead of 900, then when we took the root of B squared and we took the root of 300, that's not a perfect square. So we would have B equal to, and we would have to say, this would maybe be 103. The root of 100 is 10. So B would be equal to 10 radical 3. And this would be the exact answer. Okay. You would not want to stick the root of 300 into a calculator and get whatever that would give you if you did that. Okay. So in our example, this is the answer. B equals 30. However, this is just to show you what that would mean by reducing the radicals, stuff you did back in chapter 2. You're going to be doing a lot of that in trigonometry. Also, remember, you can't have a radical in a denominator. So we're going to talk about rationalizing that here in a minute. Okay, so Pythagorean theorem, I'm assuming you know how to use it. That's just a super quick review. All right, now on to trig ratios. Okay, so, and these are going to be important for all of the trig that we're going to do. So we have 6 trig functions. We have sine. Its abbreviation is SIN. We have cosine. Its abbreviation is COS. And we have tangent. Its abbreviation is TAN. You should have used those, at least those 3, in geometry. However, each of these 3 have reciprocal functions. And so 1 over sine is called cosecant. Its abbreviation is CSC. We have 1 over cosine. Its It's secant. It is SEC. And then we have 1 over tangent, which is cotangent. And it is COT. Okay, so these three are the reciprocal functions of the original ones. Okay, these guys. But all 6 functions are super important to know for your trig ratios. So going back to, I don't know if you remember these, but we're going to use the abbreviations now when we do these. So when you say, don't say sin, say sine. Okay, so, and we're going to throw something called theta. This is the symbol. It is the Greek word theta, and it's used to represent an angle when the angle is unknown. Okay, so here are your trig ratios, and they look like sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. So if these three are the reciprocal functions, then cosecant of theta is the flipped over fraction here. So it's hypotenuse over opposite. And secant, oh, my dogs are trying to bark at each other. Cool. Is hypotenuse over adjacent. And cotangent is adjacent over opposite. If you don't remember what the word reciprocal means, it means flipped fraction, right? And so that's what's happening. This fraction is getting flipped over right here, right? So we're just flipping them all, and that's what's going on there, okay? So here is how those are going to be used in this upcoming section for you. So these are going to take a little bit of practice for you to get comfortable, but you're going to have a problem that's going to say something like this. Given a right triangle where A equals 1 and B equals 4, find all 6 trigonometric ratios, period, answer exactly. Okay, so the first thing you should do is find the length of your missing side and draw pictures for these. Okay, so when you're doing trig, draw pictures. I can't encourage that enough. If you come to me for help, I'm going to ask you where your pictures are if you don't have them. So we're going to draw a picture. Okay. You guys have to decide where A and B are. I like my A down here. You can put it wherever you want. So I know little a is 1, which means it goes across from big A. So A equals 1, and B is 4, which means it's down here. Okay. And then we need to find C. Okay, so Pythagorean theorem. So we're going to use Pythagorean theorem to find the missing side. It might not always be C. Okay, so here we're going to go A squared plus B squared. So 1 squared plus 4 squared equals C squared. So 1 plus 16 equals C squared, which is 17. And if I take the root of each of those, 17 is prime, so C equals the root of 17. So, okay, now what you're going to see in varsity is something like this. You're going to see, let me throw these in purple, the sine of A, cosine of A. So they're telling you what angle they want you to use, the tangent of A. I don't know where I'm going to have enough room. And then they've got, I'll put these over here, cosecant of A, secant of A, and the cotangent of A. Okay, so if this is the angle we're using, that's where our theta is, then when we talk about opposite and adjacent and all those other good things, we need to know what those things mean, right? So opposite is across from. Did I already do that somewhere? Across from. And adjacent means next to. So if I want the side opposite the theta, that's going to be right there. So this is going to be the opposite side. And the side next to that is B. So this is going to be adjacent. And obviously this guy's the hypotenuse, right? So I like to label my opposite because that one's obvious to me all the time. So is the hypotenuse. And then that leftover one, the one next to the angle, is the adjacent side. So those are the ones that I need to fill in my ratios that we wrote down on the previous screen. So sine is opposite over hypotenuse, which is 1 over the root of 17. Well, if you recall, we can't leave a rad on the bottom, so we have to rationalize that by multiplying it by rad 17 over rad 17. And that's just going to equal rad 17 over 17. And that's all you're doing for these. You're finding the ratio, okay? So this is what that answer looks like, rad 17 over rad 17. Okay, so the next one, cosine is adjacent over hypotenuse, and adjacent is 4. So this is 4 over rad 17, but then we have to multiply those by rad 17 over rad 17 and rationalize that denominator. So that answer is going to be 4 rad 17 over 17. Okay. And tangent is opposite over adjacent. And if you don't know these by heart, these trig functions, you should keep writing them down until you know them, because there's a lot about trig that just requires memorization. And we're kind of going through this a little rapidly. I'm not able to spend as much time as I'd like on it because we just have like 2.5 months. So keep writing them down. If you write them, you'll commit them to memory. So opposite over adjacent. Opposite's 1, adjacent's 4. So that's 1/4. And we don't need to do anything to that. We can't reduce it, simplify it, do anything. Okay, so now when you do your cosecant, remember that this is the reciprocal of sine, right? So if you take this piece that you originally wrote down, well, the reciprocal of that's going to be rad 17 over 1. So that's just rad 17. The over 1 part doesn't matter, right? Secant is the reciprocal of cosine. And so that's over here, reciprocal of cosine. So that's going to be rad 17 over 4. That's the answer to that guy. And then make sure that your radical is on the top like mine is. Make sure it doesn't look like rad 17 over 4, right? That would be the radical over the whole fraction. This is not what you want. Make sure you're real specific about how you write that. And then the cotangent is the reciprocal of tangent. So if we flip this guy around, we just get 4 over 1, which is 4. Okay? And so that's what you're going to put into the varsity assignment. So your answers over here are these guys because they don't need any simplifying, right? So you could, if you really wanted to, you could rewrite, hypotenuse over opposite right here, hypotenuse over opposite. And you could go rad 17 over 1, rad 17 over 1. I mean, that's what that is. Or you can just flip this fraction over and do that. That's all I'm doing. So you can make it simpler for yourself. Okay, one last little note that we have. Okay, so here's a note about angles in trig. Okay, often they're going to be in Greek. So often be in Greek. Okay, so if you see, instead of an A, you might see an alpha. Okay, so this is alpha in Greek. And that would go with, so this would be the angle, right? And that would go with side A. Okay, instead of a B, you might see beta, and that would go with side B. Okay, instead of a C, this one looks a little weird. This one's called a gamma. It almost looks like a weird little R kind of. This is gamma, and that will go with side C. So you will see these not in this assignment. And then also theta is very common as a generic. Sorry, I got angle. So yeah, you're going to see these things in another upcoming assignment. It might not be, okay, well, 5.5 for sure. I think you'll see these in 5.5, but they're definitely upcoming. You're definitely going to see thetas all over the place. I think even in the next section. Okay, so I just want you to have a clue what you're looking at. All right, so alpha A goes with alpha, this guy. That's an angle. Remember, that's an angle. These are all angles. Okay, beta, this guy's beta, angle, this guy's gamma, angle. So these are angles. Okay. All right, so I think that's it for now. This all goes with 5.2. Oops, 5.2. Okay. If you have any questions, if you don't really remember much from your right triangle trig class, this is just an intro. In the next section, we're going to be finding missing sides and angles. I'll give you some steps, but you're going to do both in the varsity assignment. So, okay, well, toodaloo for now.